I got the paperback.
Paperback.
Yeah, I cried. Yeah, I ordered mine on Monday. It's like 2 days shipping. Yeah. So worth having it. Yeah, I tried to get
I'm never gonna write that good again. It's a fluke. I guess I should always write that for letters.
Yeah, mine was a fake one.
It's the same thing as like a. So which one? 68% chose mashed potatoes. You don't. That's what they do with the data. This is the actual data.
See the number you see with it,
You don't
percent.
You don't. The number doesn't crap.
That is just what you do to manipulate.
So this is the actual data.
That's the actual.
It says like, can you multiply mashed potatoes? Can you subtract mashed
Multiply
potatoes?
mashed potatoes times carrot.
Yeah, right. So it's nominal. So it's purely nominal.
You can't order a mashed potato
The number of woodpeckers in a tree.
ratio.
No, because you can divide.
You can have
You can have 4 woodpeckers in a tree. 2 woodpeckers in a tree. Divide it and you get half the woodpeckers.
No. The variable should be whether or not they're going to vote.
If you can
Yeah, I'm with you. I think I underlined it for myself.
Okay, I was like, is that not the right word? Okay.
No, you're fine. You're
I
fine.
wrote ratio.
Then, yes, this one helps. I know why that's. So, can you put a question mark here?
No, not the average.
No, so your population,
Does?
before they choose them, they can't give them the drug.
The street.
So once they choose them, then they can give them the drug.
1 people in the store.
So who are they choosing from? All AIDS patients. They're not just choosing from the people that take the new drug because they can't even take the new drug until they get them.
1 each, 1 1.
That's just
You
like.
don't put average.
That's just like. Oh, you get 5 people in that club.
What?
Yeah, you have to have a whole number. So it's the street, that's right. It's not the average number.
You can't give them the new drug until they
It does
take
get
it
cost of
safe.
values because
They're not going to. Yeah, the parameter is going to be the average length of time they live that every AIDS patient would live once they start the drug. I think you're getting those mixed up. The population, the group that I choose from, are all AIDS patients. Nobody's taken the new drug yet. I'm not just going to sit there and wait for somebody to steal it and start giving it to people and go, oh, let me take it.
Yeah.
Okay. Not a big deal, guys, but still, it's a little.
Yeah.
You can't get it until you pick it. Yeah. The parameter takes care of what I think you're worried about. You want to say something about what would happen to the population once they start taking the drug. That's what you in the parameter.
Huh? So I can get up to a 91. I just did grade of all, which would mean it's a parameter because it describes the population of everyone. I didn't read of all. I just looked at the number.
Oh, yeah. So the most watched television show, it would just be The Simpsons. This other stuff would be other data.
It's just
Well, I was just saying, like, if they survey 100 people, 40 people say,
there's no order to mashed potatoes.
I was just
Yeah, so that's, there should be numerically. That's it. Okay. Yes. Okay. All right, guys. We're going to do the equivalent of make sausage. You're going to see a mathematical formula get put together, which I love. You guys don't often see that. Statistics, this is beautiful. We have something we want to say, and then we make the data do that. So, for example, I already talked a little bit about this. We've determined, what we do is we normally use the mean. The mean is the one that kind of wins. We've already talked about sometimes is not the best, so there are alternate ways to do things, but the mean is normally the best thing, and that's because it actually takes into consideration what the values are. So normally that's the best way to go. There are situations where the median is better. But we also said that by itself, that's not good enough. So if I told you the average on the quiz was an 82, does that mean that everybody did well? No. And in fact, if my spread of my data, the bigger the spread was, the more likely it might have been that more people did bad. You with me? So an 82 average is great, but without an idea of the spread, I don't know how generally great it was. Does that make sense? So, you guys with me? 82 average is good. But if the standard deviation had been like 3, for you guys, that would have been amazing. So what would that mean? That means that you were closer to the average on average. Everybody's quiz grade would have been closer to the average. So what I want this number to do, I want it to measure the spread. How often do the data points get away from the middle? So really what I need it to be is an average distance from the average to every data point. Now think about that for a second. The average distance that a data point gets away from the middle. If the standard deviation is 0, what does that mean?
0 away from the average.
So the data points on average get 0 away from the middle. So that would be as if I had 3, 3, 3, 3, 3. They're all the mean. They don't get away from the mean at all. The minute that some of them get away from the mean a little bit, the standard deviation starts to go up. So which one of these will have a larger standard deviation? Beautiful. Because more of them are further away from the middle. I like it. Maybe you guys. So that's going to influence, that's going to totally tell us how to construct the formula to do what I just said I wanted to do. All right. Now, let's assume these are, for right now, let's assume these are populations. The formula is going to change a little bit if they are samples. So we'll talk about that next. Once we get the formula created, we'll tweak it a little bit. Okay. One more? Yeah. So hopefully it makes sense. If I want to get the average distance that every data point gets from the mean, what's probably the first thing I want to calculate for every data point? If I want the average distance they all get away from the mean, I need a list of distances, right? If I wanted to get the average men's age in this classroom, I need a list of men's ages. Holy shit. So if I want the average distance from the mean, I better get a bunch of distances from the mean. So this column here is going to be x minus mu. Because difference between two things, that tells me how far apart they are. What is the mean for these? Hopefully this is something, yeah. The sum of these is 3, 6, 9, 10, 15. So the mean is 15 divided by 5 is 3. So this will be 1 minus 3 is negative 2. It's crazy. 3 minus 3 is 0, 0, 0. And 5 minus 3 is 2. All right. So 3 of the data points are the mean, so they're going to be 0 away from the mean. And 2 of the data points are 2 down and 2 up. Now some of you guys might realize, mathematically, I don't have distance up here yet, and I'm not going to be honest. How do I get the mean of anything? A list of stuff. Add them all up. If I add these all up, what do I get?
0.
Oh shit. In fact, every time I do this, I'm going to have these add up to be 0. Because the mean kind of is value-wise in the middle of the data. So there's always going to be equal amounts negative and positive around the mean. Yes, sir? Well, what's 1 minus 3? Yeah, negative 2. 1 minus 3 is negative 2.
Oh, 1 minus 3.
Yes. Because what's... Yeah. Now, just to cut to the chase, in mathematics, what tells you distance?
Absolute value.
Absolute value. Unfortunately, what does an absolute value look like if you graph it? If none of you guys remember.
A V.
A V. bam. Is that an airplane you want to be on? And you're gonna, boom, and you're all dead. You're all up against the side. You're dead. I don't know if you realize that. That would be huge G's right there. That'd be infinite G's. It's crazy. So mathematically, this sucks. There's a kink in it. There's a hard turn. We don't like that. There's a better way to make these negatives go away. That's the real problem here, right? Some of these values are negative. So absolute value is the most basic way to do it, but that's disgusting. And there's other issues with it. It's a little bit above our pay grade, I guess you could say. What's another way to make the negatives go away? Square. Now, if I square them, at the end I'm going to have to square root them. And that makes sense. Why are we squaring these values? Because some of them are negative. Okay. Yeah. So what do you get when you square those? You get 4, 0, 0, 0, 4.
What do you think this for?
So again, an absolute value is an option, but there are mathematical reasons why we don't do that. To be honest, it is done, and it's something called the standard error. It's not called a standard deviation, but it's not used very frequently. So again, I really want you guys to understand this. I'm trying to get an average distance. If I do this, every time I do this, these will add up to be 0. So then my number would always be 0 for everything. Okay, that's not good. So how do I make it better? Absolute value, but that's got some issues. So what's another way to make it better? How else can I make negatives go away? Square them. And then that means at the end I got to take a square root, right? So why am I squaring them? Just to make the negatives go away, as long as at the end I square root them. Okay, let me stop for a second. Oh, you guys look so excited. Please, dear God, stay with me. So the only weird thing we've done so far is the square. But why did we do it? To get rid of the negatives, that's it. Now how do I find an average distance? I add all the distances. Oh shit. I'm going to add all the square distances and divide by how many there are. And then I'm going to take square root, because I took a square in the middle. So how do I find the average distance from the data points to the mean? I add up all the square distances, divide by how many there are, then take a square root. That's going to be what we call the standard deviation. That's the spread of the data. That's how far away from the middle they get on average.
Is the difference between the population one and the sample one, or the data, like number one, they're like doing with like chemistry stuff? You do n-1 on the bottom?
Yes. Okay, good. We're getting there. Yes, sir.
You're subtracting the median right there, in the second step?
No, it's the mu. It's the mean.
Oh, the median?
Yeah, the median would be x with a tilde.
Oh.
Yeah. Okay, okay. All right. Let me make some room over here. We'll do work with data B here in a minute. So below that, if you want to, you can do this on your notes. So here's what I propose. So again, this is population data, right? So we're going to use a Greek letter. Not surprising. And just to remind myself, I'm going to put a square on the symbol just to remind myself I have to take a square root. And the symbol I'm going to use, since this is standard deviation, I want to use the Greek letter S. I can't use the capital letter because that's sigma. I'm already using that. Shit. So I better use lowercase sigma, which looks like this. Looks like a fat R. So let me show you. Start in the middle. Go around like that. That's sigma. Don't just make a letter R. Actually try to make the symbol. Depending on the way you feel, you can have a skinny sigma. You can have a fat ass sigma. Whatever the hell. I'm not sure why that's blowing people's minds right now. It's just a swirl. All right, you guys cool? So what is this going to be? It's going to be adding up all of these and dividing by how many there are. That is the formula for the average. Desperately want this to make total sense. That should be the idea of spread, is the average distance from the center to all the data points. That makes sense. That should be what the number is that tells me the spread. So how do you find the average? Add them all up, divide by how many there are. Now, is this the standard deviation yet? No, because we haven't taken a square root yet. This number is what we call the variance. This is called the variance. After you take a square root, that is then the standard deviation. But let's see what we have so far, number-wise. What is the sum of my x minus the mean squares? 8. I love it. Did you plug any shit in here?
No.
No. You need a bunch of those, and then you add them up. Please, dear God, don't make that harder than it is. So, looking at this whole thing is going to be replaced by 8, because that's what the sum of those is. Don't start trying to plug stuff in here. That doesn't make any sense. The sum of these is 8, and what's n?
5.
5.
1.6.
1.6. So the variance is 1.6. So what's the standard deviation?
1.23. 1.3.
It's 1.2 somewhere.
1.26.
So here's the thing. You ready? You always go at least 3 decimal places for standard deviation. 1.265. 265? Okay. I'll tell you this right now. If you take everything out 4 decimal places, you're golden. Standard deviation, at least 3 places. There's going to be some other stuff later in the semester. There's going to be at least 3. There's going to be some that's at least 4. Just take everything out to 4 places, you're golden. If you're worried at all. Okay. So what does that mean? I don't know. Shit. Oh, yeah. On average, every data point in here gets 1.265 away from the middle. And why isn't it like perfect? Because we squared things and then square rooted. It kind of throws off a little bit. It's not linear then, but oh well. So if I do that other set, yes.
What if you don't have negative?
What if I don't have? You always will. If you don't have any negatives when you do this, you have done something wrong. Because is it possible for the mean to be lower than all of your data points? Let me say this again. Is it possible for the mean to be lower than all of your data points? No. Ain't no freaking way in hell, right? So if I said 7, 8, 9, 10, you said the average of that is 6. Isn't that a problem? You can't average numbers and have the average come out to be less than all of them. Please tell me that's... I'm going to have to leave. You guys aren't reacting. Does that make sense? If that doesn't make sense, that's an issue. You can't average a bunch of numbers and have the average come out less than all of them or more than all of them. It's impossible. If you think I'm wrong, show me a list. Is that all right? You guys? No? Okay, I'm not sure what's happening. All right, what's the average there? 4, right? Now, even if I make this 500, it's going to be higher than 4, but it's still going to be less than 500, of course. Because these are going to bring it below 500. There's no way the average can be more than all of your data numbers or less than all of your data numbers. There's no way. So something is going to be negative in this list. Okay, maybe. Okay, so that other list, everybody have this here? I've got a handout too that's got all this kind of worked out, an example. That other list of data that look like this, is it going to have a bigger or smaller number here? What did we say? Was it more or less spread out? More spread out. So this number should be bigger. Does it get further away from the middle on average? Yes. There's 2 more data points that are not the same as the average. So it should have a larger spread. So let's try this. Is the mean, what's the mean?
3.
Still 3, right? And it makes sense. I took that down by 1, I took that up by 1. So the mean is still 3. So what's 1 minus 3? Still negative 2. 2 minus 3, negative 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3 is 2. I still have equal amounts negative as positive. Now this is symmetric. You see this data is symmetric? If it wasn't symmetric, then these wouldn't be the same, but they would add up to be 0 still. They have to be. That's what the mean does. It's in the middle of your data according to the values. Now when I square each one, what I have 4, 1, 0, 1, 4. So what's the sum of those now? 10. So now up here I would put 10 over 5 is 2. And the square root of 2 is?
1.414.
Yes. Cool. So let me give you this handout, just so you can see what I've done for you. That's my hope. We'll find out. At least I have the answer key for you guys. Yeah.
So is the n minus one, is that like when you're looking at like sample numbers that are popular?
Yes, cool.
And why, or never mind, okay.
I'll tell you. All right, so the main difference between what we've done so far and what I just gave you is that what I just gave you is about samples. And it makes sense that we normally deal with samples in statistics. So let's talk a little bit about why the formula has to change. So, anytime I take a sample, the things that I discover from the sample are not the actual overall values, obviously, right? Let me say this again. There's an average age in this room currently. It's just the easiest thing to talk about right now. Right? There's an average age of all the students in this classroom. You with me? Mm-hmm. There just is. If I take a row and find their average age, will it equal the average age of everybody? Is it possible? Sure. Is it unlikely? Hell yes, right? I'll bet you anything that their average age is not the same as everybody else. So think about this for a second. You guys with me? Their average age, let's just say that I happen to pick a really young row. They just happen to be younger than normal, right? Than what's happening with everybody. You guys with me? So their average age will be less than everybody's average age. So will their ages be closer to their own average age or to the average age of everybody? To their own. Of course, any row that I do, their ages will be closer to that average than the average for everybody. Does that make sense? So when I take a sample, the number I get for the standard deviation will be smaller than it's supposed to be. What did we just say? Their ages will be closer to their average than they would be to the actual overall average. So their spread will be smaller. Now again, do you have to understand every explanation I give you? Not really. No, you could just throw shit in the formulas and go to town, right? My hope is you understand the idea behind it. I'm not going to say that one time. So here's what we do. Now, I'm going to get into this whole why is it n minus 1 thing a little bit later in the semester. But if I have a sample, the one thing I'm going to change, besides, the symbols, that'll be x bar for sample mean. That'll be now, this will be S instead of sigma. We use our letters for sample stuff. Everybody with me? Down here, if I want, so again, their standard deviation should be smaller than it should be for the whole standard deviation because their ages are closer to their own mean. So how do I make a division problem? How do I make the answer bigger? Because the problem is it's going to be too small. How do I make the outcome bigger? I divide by less. So I'm going to divide by n minus 1 instead of n. Now, why is it exactly n minus 1? There's a lot to that story.
And you very briefly try to some are like give like a short answer for why it's n-1 specifically?
I mean, mathematically it would be difficult. One way to see it is if I took every possible sample of size like 7, I mean every possible sample of size 7 from this class, and I calculated all the samples using n-1, and then I averaged them all up, it would equal the standard deviation for the whole class. So that's like the empirical way of doing it. That's like the computational way of seeing it happen. The mathematical theory behind it is a little more in-depth, involved. You with me?
Yeah.
Okay, so it's what we call an unbiased estimator. So if I divide by n-1 instead, that raises all the sample standard deviations up a little bit so that when I average them all together, they actually equal the standard deviation of the whole class. That's the idea. So it's n-1 that does that exactly. So really, right now, all I need you to realize is a population's variance is exactly what I expect an average to be. Sum of something divided by how many there are. The tweak I have to make for a standard deviation is to make it a little bigger than it would be otherwise, so I make the bottom a little smaller.